so that we don't have any interruption. Is that okay with everybody? And just raise your hand, and we'll definitely keep an eye on that. Okay. You let me know when James starts. Okay.
Okay, and James, do you prefer questions after or kind of in between?
I'll pause and we can do it in between.
Okay.
Okay. All right, let's see. Is this recording? I see the red. Yes. Okay. All right, let me turn off my screen. All right, it's all yours.
All right, can you see my screen?
Yes.
Yeah, awesome. Well, welcome everybody. That long, great introduction. It's a kind of way to say I'm pretty old. I've been doing this for quite a long time, going back to my COBOL days in the 80s, and first using SQL Server 1.0 and OS2 back in 88 or 89. And my pretty much the last 8 years, except for a short stint, has been at Microsoft. And I'm currently in Microsoft Consulting Services, where I help customers build solutions. Most of them are data warehouse type of solutions. And this has been a popular topic when we get into all these concepts, which I'll talk about briefly. But I like to level set, especially with people who are not used to building data warehouses, on what does this all mean when you talk about a data warehouse and data marts and Kimball and Inmon and data lakes and such. So I'll cover that in the next hour. And if you have any questions along the way, just raise your hand and I'll pause at a few after every handful of slides to take some of your questions. So you can come off mute or you can type it in the chat window. So I know a lot of you may feel this way. If you try to build your data warehouse on your own and try to learn all about it, you may feel like this guy, where you're passed out drunk in a Denny's parking lot. So we're gonna try to prevent that happening. And I'll start out with talking about what a data warehouse is not. I was a consultant for many years, and I saw a lot of companies say, hey, we've implemented a data warehouse. And some of them just simply copied a production system, an OLTP system, and prefix it with DW. That's not a data warehouse. It's not a copy from multiple tables from a source system union together in this large complex view. It's another mistake I've seen a lot of customers do when talking about data warehouse. It's not a dumping ground for various tables from source systems with a lack of design. And a lot of times somebody says, hey, we need a data warehouse, and they quickly dump some files in a relational database and thinking it's going to be a temporary solution. It winds up becoming something much more. So you have to put a lot of design into it, or I wouldn't consider it a good data warehouse. Now, why use a data warehouse in there? The idea is, if I have a bunch of source systems, and I call them online transactional processing, meaning they're CRM, ERP type systems, or some homegrown application where you're doing a lot of updates, inserts, and deletes. And you need to collect data from a lot of these systems and get better insights into your data, make better business decisions with your data. And you don't want to query the source systems for various reasons. One of them being, if you have this production system, say it's a ERP system, and you're running queries against it, it's going to spike the CPU. People are going to start complaining that they can't do data entry into the system in there. So having a copy of the data in a data warehouse is one big reason for doing it that way instead of going against your source systems. You can also, when you copy it into a data warehouse, you can optimize it for read access, where that source system, an OLTP application, is designed many times for writes and not reads in there. So it's not performant to begin with, but a data warehouse can make those reads much more performant. You can also integrate many sources of data. So many times customers will have dozens, if not hundreds, of source systems that they're all going to combine into a data warehouse, a single version of the truth, and to get that business insights from it. You also can keep historical records in a data warehouse because you can save data over time, as opposed to a source system where a lot of customers would purge the data after every few years, so they would copy it out and create these hard copy reports. Well, with a data warehouse, you don't have to do that anymore. You can always go back in time and see the data whenever you want to. You can make it much easier to understand the data when you create a data warehouse, because the source systems, I've worked with a bunch and they'd have some weird table name, sometimes something like T116, and you don't know what that means. And so if an end user is trying to query it, they have to know these conversions of all these names. Well, you can do that when you create the data warehouse and name the tables and fields something that's much more understandable. You can also protect against source system upgrades. So if I am updating, if I have reports going into the source system and then I change the tables and fields behind it because it does some upgrade, all that stuff's going to break. All the reports are going to break, as opposed to if you create a data warehouse, the only thing that may break is the ETL. So you just got to fix that. So it's a much more quicker fix than having everybody going into the source system. Also, copying the data out, you can do things like master data management. So if you have a number of source systems that have all these different customers, but some of them are the same customers, you can create golden records to avoid having duplicate customers in there. And you can also build hierarchies. It could be a hierarchy for companies or products and such. All that could be done outside of the source systems and inside your data warehouse. And then the idea is you want to create a data warehouse that makes it very easy for end users to do their own self-service BI, and they can create their own reports without getting IT involved. And then you can also improve the data quality in the source systems, because as you copy data over, you'll find all these problems with it. For example, I've seen customers who have systems where the birth date's in the future or it's 200 years old because the source system was required to enter the birth date, so they just put anything in there if they didn't know it in there. So you can start seeing these problems and plug the holes in the source system. And you get one version of truth by centralizing everything. And then it's easy to create BI solutions on top of that. So if you think of products like Azure Analysis Services or Power BI, it's much easier to do that over a data warehouse than trying to go to a source system. So what does this look like? And why do you use a data warehouse? If I don't have a data warehouse and I'm trying to generate reports, it'll look like on the left where you have all these
James,
different.
sorry to interrupt you. I see someone with their hands up. Did you want to answer their question now, or did you want to hold off into a certain spot?
Yeah. Let me go ahead. Sorry, I missed that. So
Okay.
you want to come off mute and ask the question?
Yeah. Hello. Yeah. Can you hear me?
Yep.
Yeah. Sorry. I'm on the move. Maybe my audio is not that great. So my question is, you did say about why use a data warehouse, but there is a recent trend, or at least what I see is sort of an hybrid transactional analytical processing systems. Like I think probably SAP HANA is quite popular, and I also see Microsoft is also promoting on Azure. So if that system is good enough, then why do you need to build a data warehouse?
The systems. So what are you talking about OLAP systems?
What I understand from these analytical processing systems is that you can directly query on the back end of the OLTP systems, and you can do operational analytics. Yeah.
Yeah. So what he's referring to is you have some systems like SQL Server where you can behind the scenes do what's called HTAP, which means it creates a copy of the database and it's optimized for read. So you're not messing with the source system. So that solves a couple problems. One is reducing stress somewhat. You could still have a problem because it's on the same box. And it's also helps number two here on there, optimize for read access, but it doesn't address everything else. If you want to integrate multiple sources of the data, if you want to restructure the names and make it easier to understand, if you want to protect against source system upgrades, everything else on here doesn't apply to that. So that I don't see that used very much at all because it only gets you a little bit along the way. It only solves a couple of the issues. It could be good for quick, easy reports that don't need to combine with other source systems. But it's not going to give you a full data warehouse and solve most of the issues you see on here.
could that be sort of a departmental data warehouse kind of, let's not say data warehouse, but a departmental analytical kind of a solution, but it can never be an enterprise solution?
Yeah, that's a good way to
Is
think
my
of it.
understanding correct?
Yeah, that's a good way to
Yeah,
think of it.
okay.
Yeah, I like that. I may use that.
Thank you.
Yeah. Good. So I'll pause every few slides or just keep your hand up and I'll notice it next time. So why use a data warehouse? If we don't have the data warehouse and we're trying to create a report, say from finance or marketing, they have to go against all these different source systems. Where if I create a data warehouse, an enterprise data warehouse solution, all those source systems are copied into a central location. So either any department just has to have one direct access to that enterprise data warehouse. They don't have to go against all the different source systems on there. So it's going to save you a ton of time building reports. So there's work involved in copying all to a central location, but it's going to greatly speed up the ability for end users to create reports and dashboards. And it's also going to allow them to query and slice and dice data in ways that they are not able to do it on a production system. Most customers, when I talk to them, I go through the different stages they can be involved in creating data warehouses. The first stage is a lot of customers are still in the stage, unfortunately, where they have data everywhere and it's really hard to use it. They have spread marts or Excel spreadsheets everywhere. And they're trying to get at least to stage 2 where they're centralizing all the data. So all those marts and Excel spreadsheets and data warehouse independent databases are being copied into a central location. And so most customers are trying to get to stage 2 on that. Once they get to stage 2, which is great at historical trends and reporting, they want to get to do more with the data. And that's where we get predictive and transformative analytics. In that I can not only look at historical trends, but I can predict by creating ML models on top of that. So I can predict customer churn. I can predict when a part's going to fail. That's where a big tidal wave I feel is coming with customers who are gathering all this data, generating the historical reports, and then they go, wow, we can get even more value by start building machine learning models on top of it. And the idea is this gets you digital transformation to get to stage 4, where you want to be able to ingest data and want the size, the speed, or the type. And that involves a lot of work up front, but you build a solution that lasts for a really long time and you get any sort of data ingested and make better business decisions because of it. There's a confusion a lot of times between a data warehouse and a data mart. With a data warehouse, think of it as I take all my data and I centralize it. Multiple subjects of data, granular level of the data on that. A data mart is a subset of that data warehouse, usually afterwards, meaning I collect all the data in the data warehouse and then I may break out pieces. Maybe I need sales data and I just need that and I pull it out and put it into a data mart. And this has changed over time with where we can land this data mart, but you can think of it simply as another database that is being used for the sales department. And so it could be that it's optimized more for them than it would be against a data warehouse in there. So think of the data warehouse has all the subjects and the data mart has one or two just subject in a particular area. And that helps when, as we talk forward, to clarify what a data warehouse and data mart is. There's 2 approaches for building data warehouses, the Kimball versus Inmon. This has been around a while. I put this slide up here and I have used this for many years because there's a lot of contention from people who have different viewpoints on how to build data warehouses. I'm focused on the relational database aspect of building data warehouses, which is not really changed, which is not changed out inside of a relational database. If we look outside of it, when you start talking about data lake and data lakehouse and data mesh, it's changing the way things are done outside of the relational database. But inside of it, which most companies have and will continue to build relational databases, this is the following slides apply. The way to think of it is Inmon is focused a lot on relational, the third normal form, and Kimball has a dimensional model or what's called a star schema. And if we look at relational model, that third normal form, it's normalizations, it's doing a lot of joins. It's great for end users who want to access the data, but IT goes and is the go-between a lot of times between that, because they got to create the views that join everything together. So if we think of this model, this is the way you see a lot of the source systems in there, and you're kind of carrying that over into a relational model. If you're looking at the Inmon method, the Kimball method is going a step further and creating a star schema, which is taking that third normal form and then denormalizing it and creating this star schema approach. And that makes it a lot easier for end users to access that data directly. And then you can do things like slowly changing dimensions and track data as it changes over time, so you can get correct historical records over it. And what that looks like at a high level is a relational model on the left-hand side, where those who use databases are familiar with this, the way it looks like. It could be a lot of small tables. Dimensional model combines a lot of those tables. In this case, it would denormalize the product table, which are about 10 tables here, and create that as a dimensional table, and a sales fact table, which has the main grain of sales, and it's linked to the product table. So we do a lot of work to create this dimensional model to make it easier for end users to access it. And Kimball was the first one that came along 20-something years ago and talked about this dimensional model, also called a star schema, on that. And this is used frequently today. So a lot of times customers will create a data warehouse, go from the OLTP systems into this relational model, and then they'll go a step further and create a dimensional model on top of that. So the Kimball method, if you read his book, which is still relevant today, he talks about having a logical data warehouse. So it's made up of these individual subjects, but logically combined are a data warehouse on that. And it's very heavily driven by the end user, the business participant. You have these dimensional data marts that are optimized for reporting. You have things like conformed dimensions, which means I can have like a date dimension that can be used across many different subjects. And so I'm not having to recreate a date dimension. That's called the conformed dimensions. And then there's usually less ETL in this, because you're copying data from the source systems into a data mart. Sometimes it's called a cube, and that's it. So there's less ETL, less data duplication in the Kimball world. In the Inmon world, it's you copy the data from the source system, what he calls an enterprise data warehouse. And then from that, you create data marts. So it's 3 tiers, an extra layer: data warehouse, data mart, and then on top of that, you can have cubes, which are kind of an old term now, but if you look at Power BI, they have tabular models. It's a way to aggregate the data to make it easier and quicker to consume in there. If we look at the way this is in pictures, the Kimball method is taking data from your source systems, and I'm still using SSIS, even though that's getting to be sort of old school. If we look at on-prem, most customers are using SSIS still. If we go to the cloud, talk in Azure Data Factory. But assuming this is on-prem, and if it's in the cloud, you just swap out with the Azure Data Factory. But the idea is some ETL tool. It could be Informatica, and you're going to pull this data into a staging area because you want to avoid having a lot of stress on the source system. From the staging area, you then pull it into a data mart, into that star schema approach, that dimensional model. And from that dimensional model, you can then create cubes. It could be a multi-dimensional cube. It could be a tabular model. It's an aggregation of the data. And to explain that a little further, if I keep things in a star schema, it could be tables within a relational database in something like SQL Server. But that still can be slow. If you're querying that and you're doing a large tables with millions or billions of rows, and you're trying to sum up the data, it could take a long time. I could use something like a multi-dimensional cube where it pre-aggregates everything. It runs at night, has aggregations, and then when I query it, it's really quick because it's just one select statement off of a predefined aggregation in there. So that's the idea of creating the multi-dimensional cubes. If we look at the Inmon model, he goes from taking similar OLTP systems into a staging area, but he has another layer where he talks about this corporate information factory where it's copying all the data into a enterprise data warehouse. From that, you create data marts, which in his view are still third normal form. And then from there, you can create the cubes, a multidimensional or tabular model on top of it, and then you report on top of that. So you can see this extra layer here where in the Kimball methodology, he has individual data marts, but they're logically grouped together to create a data warehouse. In the Inmon method, he has a data warehouse that's physically a copy of the data. And so what people ask, well, do I really need to create a physical copy? And can I just use the logical? And most times you want to go to this enterprise data warehouse. You want to use the Inmon method in that you have a single version of the truth. You can make it easier to build dimensions from that centralized enterprise data warehouse instead of going back to the source system, which you kind of do in Inmon. You can make it easier to spawn off data because it's all centralized and I can create copies of that and have that consistency by not having people going all back to the source system and incorrectly doing things differently than other source system, than other data marts that are being created. There's less ETL refresh because you're only refreshing from into one source system into instead of having many different data marts that are all doing their own ETL, which is the biggest reason that people shy away sometimes from that Inmon Kimball method is having all these data marts, sometimes copying the same data means a lot of additional ETL. It's one place to control the data. So if I'm governing the data, I only have to govern it in this one location instead of trying to govern it in all these individual data marts. I will say sometimes you may want to bypass this enterprise data warehouse if you only have a few sources and you need to get some value out of it quickly. I can bypass that. The difficulty that could happen is if you start building up your data warehouse then and you bypass that step, it could make it really difficult to go back and fix things. So which model to use? Most people now realize the models are not that different. And over years, if you look back at the history of both those individuals, they've kind of complemented each other, even though that a lot of people would complain about one or the other, in which camp you were in. They've kind of come very close to be similar in there. It really boils down to an Inmon. You create this normalized data warehouse, this enterprise data warehouse before creating these dimensional data marts. And Kimball skips that normalized dimensional warehouse, the data warehouse part of it. But if you make tweaks to each of the model, they look very similar, as you'll see in my next slide. And the idea is there's no one universal great solution for everybody. Find out your particular use case in your company, and then pick out the model that works best for your situation. And I always add, I don't care how great technically you design it, there's a lot of soft skills that go into having a successful data warehouse. Gartner estimates that 70% of data warehouses fail, and that's not because of technology, it's because of the people in the process. So that's a big part of getting the right people in place and defining the process. So what you wind up having with many customers is this hybrid model where they take the OLTP, maybe they have a subset of it, which could be that HTAP we talked about before, or if you know SQL Server, you have availability groups, you can have a copy of that so you're not stressing on the main system. You put it into a staging area, then you go and copy it into a enterprise data warehouse. This is third normal form. It's at the lowest grain of the data. And then you copy it into a data mart, which if you make it a star schema, then you're combining both of Kimball and Inmon. And from that, you can generate reports off of that, or you can go one step further and put it into a cube and aggregate it and make it even quicker for end users to access the data. So this is the solution I see most customers going to when they are building something, building a data warehouse, especially when it's on-prem, but even in the Azure world, as more and more people are going to the cloud, when they are focused just on building a relational database, this is the way they go. And we'll talk about options with Data Lake that are changing some of the things that happen outside of this. And then I'll also wanted to mention that if you read Kimball's book, it's called the Microsoft Data Warehouse Toolkit. It's still relevant, even though it's aged, because he talks about the whole life cycle, and it's not just about technology or building a data warehouse. Where Inmon is, his books are just about building a data warehouse. So Kimball gives you ways to collect business requirements and do the physical design and the technical architecture, and so there's a lot of great things. It talks about project management in there. A lot of great things that you can still use today when you're looking at building a solution, even if it expands into a data lake. I always tell people that should be kind of the Bible of what you use when you're trying to build a solution. All right, I'm looking, I don't see any hands up, but just put your hand up if you have a question. Jumping ahead to this is where we're going to get a little bit into the data lake. If everything I talked about is a top-down approach, meaning I'm building out a data warehouse. I know the questions I want to ask. I'm going to do a lot of upfront work. I'm going to build a database and tables and fields, and I'm going to get to the point where I can get value out of the data, but I have to do all that work. I have to model the data. Bottom-up approach is where maybe I don't know the questions to ask yet. I know I get this data. I think it could be valuable, but I want to quickly query this data and see if it's even got value before I go to the next step where I model it in a relational database. It could also be if I just want to do a one-time query or report, maybe I need a better way of quickly analyzing this data and investigating it. And I'll model it later if it turns out to be valuable. So I need something that's a little upfront work for that. And we look at the top down, this is works great for historical, as I touched on before. If I want to look at why something happened, what happened, descriptive or diagnostic analytics is called, this is what's great for the top-down approach. The bottoms-up approach works really well when you get machine learning involved and data scientists involved, and you want to do predictive analytics. They like it in a format where they can quickly and easily query the data with little upfront work that needs to be done. If we look at the data warehouse that we talked about, this is using the top-down approach. You have to understand your business requirements, you gather them, you then build out this data warehouse, and it takes a lot of time, whether you use the Kimball or Inmon method, and you get a relational database that people can start querying. But that could take weeks, if not months, before people can get a lot of value out of the data because of all the upfront work. Now what we have with the data lake is this bottom-up approach where I can take all this data, especially if it's sensor data or social media data, and I can land it very quickly in the data lake. And a data lake is simply a glorified file folder. It's like putting something in your laptop. I can copy data in there. I can copy lots of data in there, especially when you talk about sensor data, which a relational database mostly can't handle. I can put this in a data lake, and then I can use tools on top of that data lake to query that data, investigate it, and see if it's got value. If I'm a data scientist, I can do machine learning on top of that data because it's just a file folder on there. So within a matter of seconds, if not minutes, you can put that in the data lake. In many cases, it's in the cloud now. And within the minutes, I can fire up this data lake with folders in there, and I can land data in there, and people can start querying it. And if they find value in that data and they want to repeatedly use it, then you may move it on to a data warehouse. And that brings together the best of both worlds. I can use a data lake and a data warehouse and make everybody happy in a way. Those people who want access to data quickly can do it. And those people who need the work done to put it in a format that's easy for them to use can wait until it's put into a data warehouse in there and get the value out of that. So why use a data lake? I will say this slide's grown over the years. I'm not going to go through all of these, but a data lake is pretty much everybody's doing that now, especially the larger customers that I deal with. And the idea at the very least is if you're using a relational database now and you need to load data, what you usually do is you have a maintenance window, you lock people out, You load the data into the data warehouse, into staging tables. You clean it and join it, aggregate it, do all these things to it to get it ready. And then you open up the maintenance window. You hope that nothing went wrong and people can then start querying the data. So some problems with that. One is it could be expensive. The compute on a relational database could be quite costly. Usually you delete the data because you have limited space in your data warehouse in there. So if you need to go back in time and rerun something, that data has to go back to the source system. And you have this maintenance window, we have to kick people out. If I just take that part, that staging and cleaning part, and put it into a data lake, I can do that outside of the data warehouse. And I can put cheaper compute and as much compute as I want on top of that. So the data from these source systems gets copied into a data lake, which is just storage. And I can put all different types of compute on top of that. It could be Spark, DataBricks, Data Factory, and do all that processing, cleaning of the data without having a maintenance window. And then, so people can access that data warehouse pretty much 24/7. And then I may have a very short window of a few minutes where I load that data into the data warehouse and I'm off and running on there. So that right there is a big reason to use a data lake. Also, it can keep historical data because data lake storage is extremely cheap. I can keep years worth of data. If I ever need to go back and use it to rerun into the data warehouse, I can. Also, because the data lake is schema on read, meaning I just dump the data in there. I don't have to do anything in the meantime. It's just like copying into a folder. If the end user or the data scientist has the skills, they can start querying that data using certain tools that have become much easier to get value to that data right away without having to wait for it to go into the data warehouse, which takes a lot of extra time. So that's just some of them. I'll send this deck out afterwards too. But this is why every company I deal with is building a data lake. So in the end, if we look at having a data lake and a data warehouse at a high level, what does that look like? So think of the data lake as your staging and prep area. Data scientists, power users can use data in there, but most of the business people are going to use a data warehouse because it also combines or layers the metadata with the data, which makes it very easy to search through it and find what you need. Where the data lake, the metadata could be completely separate out into another folder or embedded within the file itself, which makes it very hard for people to understand what's in the data lake. So the extra work of a data warehouse is very important for those business people, especially if they're used to using relational databases. And then a lot of times companies will lock out end users from the data lake unless they're power users or data scientists because of security. The data lake doesn't have things like row-level security. So if I have a file that's got all these departments in there and I only want people to see certain departments that they have access to, in a data lake, I have to go through trouble breaking out that file and creating it one file per department and landing in folders and giving security on that. It's a very complex process. Instead, I can copy that whole file into a data warehouse and use row-level security, which is an easy method to filter out people and only see data that they're allowed to, in this case, departments on there. So there's a lot of other security on the data warehouse. There's column level security, dynamic data masking, all these things that make it much easier to do the security in a data warehouse. So this is where most customers have landed, the data lake and the data warehouse, and they separate them out by these particular use cases. All right, I'm gonna take a coffee. Anybody has no hands up yet?
I have a question for you. Have some businesses strictly went with the data lake and not a data warehouse?
Yes. That is where we get to the data lakehouse, which we'll talk about in a few minutes. The idea is, can I get away with not using a data warehouse? And the answer is yes, in some limited use cases to be expanded on. If you read my blogs from years ago, I said we're always going to need a data warehouse and not just go with a data lake, because we tried that in the 10 years ago when the data lake, when Hadoop first came out, people said, oh, look at this data lake. This is great. I'll just put all my data in there and it's this magical land of unicorns and rainbows and leprechauns and it'll come out fine. Well, that failed miserably because the data lake was too hard for average user to make sense of it. And what's changed over that with the data lake is a thing called the Delta Lake, which I'll talk about, but that's made it a little easier to use. However, and DataBricks is pushing a data lakehouse, and Microsoft's got a lot of things they're working on and already come out with to make it more likely you can use just the data lake, but the majority of cases now and in the future are still going to be you need a relational database. And VK, go ahead.
Yeah, so my question is, you just mentioned Delta Lake, and I wanted to see if the Delta Lake can replace what you mentioned about the Inmon's approach, where the first layer you build a enterprise data warehouse and then you build a data mart, right? Because the Delta Lake supports let's say a sort of a delta changes. It can track delta changes and everything. So can that replace this sort of an enterprise data warehouse kind of a solution?
Yeah, so I'll jump to those slides right now. So to answer your question, we started out with the data warehouse. It was a big handling big data in the TISA Teradata kind of thing. We went to the data lake, as I mentioned, that didn't work. We then switched to a combination, which I just talked about, which was have a relational database and the data lake. And now, a few years ago, there's been a push again for the data lakehouse, which is combining your data lake and your data warehouse and called a data lakehouse, kind of a cute term. And so what's the difference between now and in the late 2000s, the data lake? And the big difference is the Delta Lake. It's a software layer on top of a data lake that gives it additional features that make it relational database-like. For example, it supports ACID transactions. If you're familiar with that. It allows for data versioning, which is really helpful for auditing and rollbacks, because the data as it comes in there, you can always say, well, show me the data, not what it is now, but what it was 3 weeks ago. You can do that in the queries in there. It makes it easier to stream and batch data together. You can also enforce schemas, so somebody doesn't put a file in there that's blowing everything up because it's not the right schema. And the biggest reason that people use Delta Lake is because it supports delete, update, merge. And with more and more companies now trying to update data in a data lake instead of a relational database, you need support for these type of commands, which doesn't exist in a data lake. So this Delta Lake layer will give you that option on there. And it also is very much improved the performance, which is a big problem. When we had these old Hadoop clusters, it could take minutes to just do a simple query on there. So this is where we're starting to see the idea that you can use the Delta Lake. However, there are, I don't think I have that in here. There are concerns, which, oh yeah, I do have it, with this approach, in that it won't be as fast as a relational database. You won't have that security that I mentioned before, like row level and com level. It could be kind of complex for customers to navigate a file-based world, and you don't have things like referential integrity. Now, Microsoft's product has a product called Synapse that's making it easier to use. And the big one list that I didn't call out here, but is T-SQL. If you're used to T-SQL and you use Delta Lake and the DataBricks feature, you have to use Spark SQL, which is ANSI SQL, which is just enough difference from regular T-SQL for people to complain. Synapse allows you to put a view over data sitting in a data lake, and you can use T-SQL on top of that. So this is where we're adding, Microsoft's adding enhancements to Synapse to make it more likely you can start using a Delta Lake and not have to copy that data into a relational database. So hopefully that helped a little bit. I can spend an hour just on this part. But these are great questions that I can have follow-up conversations with too.
I mean, let's say if you want to build a greenfield sort of a data warehousing kind of a solution. So, I mean, so the question here, yeah, I mean, especially with the Delta Lake, there's definitely a lot of advantages in terms of cheap storage and everything. Probably, as you said, the performance would not probably be compared with an MPP kind of a solution. Yeah, so it's more like depending on the use case and what you're willing to spend on, I would say.
Yeah, sometimes I tell customers, use Delta Lake until you can't. If you start using it and you think, oh, I'm fine with some of these concerns, we'll see if it'll work. And if you get to a point where you go, well, this is not getting the speed I need, or I really need a level of security, then okay, now copy the data into a relational database, and that'll satisfy your needs.
Okay.
Yeah. Okay. Cool. So talking a little bit about why data warehouse projects fail on that, and I'll just go through a couple of these. But I've heard a lot of times people think it's easy to build a data warehouse. They don't get the users involved early on, which is a big failure. They have a timeline and they just kind of work backwards from that timeline instead of spending time on a project plan, especially when it comes down to data governance and planning for that. It could be choosing the wrong technology. People will go and complain about a technology I've found, and it's a great technology, but they're using it for the wrong use case in there. And so there were some other technologies that they need to use. So that's where upfront you need to spend some time investigating all these technologies. And if you have a Microsoft that people that you work with, like cloud solution architects, I used to be one in your company, if they have a Microsoft helping them, look for those CSAs, and they can explain all these different products for you. Other reasons, just communication between the IT and business. This is where you got to get business involved. You got to have open communication lines, or they're going to be already thinking negatively about your project, and they won't be on your side. So if you get involved early, they'll feel like they're part of the process, and they'll be rooting for you instead of having a negative eye towards what you're building in there. And then just make sure your performance issues, especially if they have something now, whatever you build a data warehouse, it's at least as fast, if not faster, than what they've currently using. And then lastly, I'll say model the data to reflect. This is where people fail. They model the data warehouse to reflect the source data and not what the business needs. So don't just look at where you're getting the source data from them and create something similar to that. Ask your business users what you can need and create a model that is a lot easier for them to consume than going against the source data. And then two things I see is hiring the wrong consulting company, especially if they don't have experience in your particular use case, and then running out of budget. And that happens a lot because the warehouse usually takes a lot longer than people expect. And they cut corners, and they don't hire, say, testers or give proper training in there. All those things need to be done in order to be successful. And how they succeed is choose the right technology, understand all those architectures and products, like I mentioned, find a good sponsor, have somebody who's directing things, whether it be a director or a project manager, have an agile approach instead of the waterfall approach to building a solution. Get people excited, and you can do that through training early on, especially if they've never seen something like Power BI, and you show them that, they get really excited at what they can do, because they can see the art of the possible. They can do things that they never even imagined before. So that I found is really helpful in getting them to be a cheerleader for what you're building out. And then Power BI is very powerful, and you can build a whole solution in Power BI if you wanted to, but it's more from department solutions in there, not enterprise ones. But it's a great way to quickly prototype and even get some quick wins out of it that could be moved on to an enterprise solution, because Power BI, you have the ability to pull data from the source system using ETL, land it into its own data lake, copy it into a model, and generate reports and dashboards. All be done within Power BI. So anybody who understands that product can start creating solutions right away and get end users or executives to see the benefit of collecting all this data and building a data warehouse. The modern data warehouse looks like this, and so if you're building out an enterprise data warehouse in there, think of the Kimball method as being in step 4, or the Inmon method. And now with the data lake that I talked about, combining the two, this is where I break it out into 5 steps for customers. And anybody you talk to is pretty much going to break out in these 5 steps. They just may call it different. You need to ingest the data. You need to store it somewhere that is in that data lake, where in that data lake, you'll have different layers. So they are folders, but you can think of a raw folder, and underneath that, we'll have other folders to break it out by date or subject matter. And then you'll have other layers where step 3 comes into play, where I transform the data, I clean it, and I land it into a clean layer. And then maybe I aggregate it and join it, and I create a presentation layer. And then maybe I copy the data and have a sandbox layer for a data scientist to use. So this gets into data lake design, which could be a long topic in itself. But you got to put the time up front to design this data lake. And then so once you transform it all, as I mentioned before, it may not be conducive for end users to query the data and report off of it in a data lake. So you want to model it. You want to copy it into a relational database. That's where you get the third normal form and Inmon and the star schema and Kimball. So you get to that step 5 to visualize it, to make it very easy for the end users to just drag fields on a Power BI platform and create reports and dashboards off of it. If you're using Azure, I listed out the products you would typically use each step. Azure Data Factory for ingestion, Data Lake Store Gen 2 for storage, multiple compute options. You can use Data Factory data flows, you can use DataBricks, you can have Synapse serverless, and then relational database, it could be SQL database, or it could be Synapse, which is for bigger data, and then Power BI for your visualization. And then the data fabric, this is a confusing term for people. I view it as just an expansion on a modern data warehouse where it adds additional functionality. So you can talk about master data management, lineage, data virtualization, real-time processing. Some people now use data fabric instead of the word modern data warehouse. But the idea, the bottom line, is just to use additional technology. So you have this fabric going out and be able to collect data no matter the size and speed with the type of it into a central location. And so that gets into data lakehouse. And the last thing to talk about is the data mesh. And everything I mentioned before talks about centralizing the data. And the data mesh has come around to be very popular the last couple of years, where the difference is decentralizing it, is keeping the data separate and the compute separate into domains. And I'm going to touch broadly on this topic because I could spend hours talking about it. But what this looks like, different than a centralized approach, is I have 4 principles that data mesh is based off of. One is each of these domains in a company, they could be, say, manufacturing, HR, sales, is now going to own the data instead of copying it to IT where IT owns the data. So each of those products are now responsible for creating their own analytics platform in there. So they will create their own data lakes and data warehouses and make it available for other people to use within their domain, but also outside of that domain. So maybe they create APIs, and that allows people out in other domains to access that data. But they're decentralized, meaning they have their own IT team, they have their own infrastructure and compute and storage, and they are abiding by some kind of contract of how they will present the data to others. So this helps with scaling, because now IT is not the bottleneck. Because if IT is doing everything, as more and more data comes in there, they may be challenged by not having enough people or not having enough technology and compute power. If each of the data products now is instead having their own IT team and their own compute, you can scale out instead of just scaling up. So more domains means more compute teams, more compute people, and more compute power on that. You also, at least in theory, are reducing the ETL into all going, instead of having it all go into one central location. All the domains are doing the ETL locally, which they may already be doing. And then you're also creating data as a product. So think of it in terms of, if I write those API calls, anybody can use it very easily by spending the time up front to make it easily available. And then that's all well and good, and that's totally decentralized. However, you do have parts that are centralized, and this gets into some other principles of data mesh, meaning I have data infrastructure as a platform, meaning I want to create a system where anytime there's a new domain, I click a button and that domain gets all the compute and storage that they need. Otherwise, it's very challenging to have every department, every domain go and create their own thing. So you create this centralized approach to helping domains build out their infrastructure. And then you also have a centralized, what's called federated ecosystem governance, is rules and processes and standards in place for all the domains to follow. Otherwise, they're off doing their own thing. And so to try to join the data can be quite challenging. So this is the approach that data mesh takes. Believe me, it is difficult to understand. You ask 10 people what a data mesh is, you'll get 11 different answers. I go into this much more detail in another deck, which I'm happy to do in the future. The bottom line is data mesh is one other architecture compared to the modern data warehouse, compared to the data lakehouse or hybrids of those. This is another architecture that's vastly different that will work, but only for a small subset of companies. So you have to have be a large company with no resistance to change, because this is a radically different way of doing things. You have to be very technology focused. If you don't have those characteristics, the data mesh wouldn't be for you. So if I had to say, at all the companies coming to me, and I'm dealing with big companies, probably 5% maybe a data mesh would work, maybe 25% a data lakehouse would work, and everybody else would be the modern data warehouse on that. So Zamek is the one that created the data mesh term. Although the principle's been around a while, she kind of packaged it together nicely. So the confusing part is everybody calls data mesh something to sell their product, and they may not use any of the principles and they call it a data mesh. So that's where the challenge is. All right, so with 5 minutes, a lot of the stuff I talked about here, I also have on my blog. You can visit for more information. There's my email. If you have follow-up questions, just shoot an email out to me. And we have a few minutes now if there's any questions. Either everybody's somewhat clear or they're all fall asleep.
I do see something in the chat. I'm not sure if you got to this. What are the best practices for implementing GDPR regulations when building a modern data warehouse in the cloud?
Oh, yeah. Those are regulations that a lot of companies have, especially in Europe, of regulations that specify how the data can be presented, especially PI data, or maybe a data can't leave a country. So when you're building a modern data warehouse, this is where you can get into obfuscating the PI data. So as I copied in there, maybe I overwrite the data as a solution for part of the GDPR. The other could be if you can't have data leave a certain country, then you got to get in a little more sophisticated solution. That's where data virtualization comes into play as one option of I can keep the data sitting in, say, Germany, and if I need to access that data, I can say only somebody in Germany can access that, and they can use virtualization software for that. As well as if you want to combine the data from different locations, the virtualization software can put a catalog on top of that so you know where that data is, and then provide the means to pull all that data together. Because at some point you have to probably pull it out of Germany, and maybe it's okay if you aggregate the data and remove a lot of, make it very anonymous, and then virtualization software can pull it all together and combine it with other data from other countries, or do something sophisticated where you have to push all the data into Germany if that's the way to go. So virtualization software could be good for that, but there's other methods, and that could be a longer conversation of solving some of those GDPR regulations.
Thank you. We also have somebody's hand raised in the chat. I think that is BP. BK?
Yeah. James, if you can go to the slide where you talked about the architecture of the modern data warehouse.
Sure.
Yeah. So, you described, what is the need for a data lake. If performance is one of the, let's say, limiting factors on a data lake, and you mentioned about the different layers within the data lake, like let's say, some vendors call it as gold, so bronze, silver, and gold. But yeah, in this case, if performance is a factor, then all these ETL processes would, no, would take a lot of time, right? I mean, to process that data, to really make the data into a transformed one, it will take a lot of time. So how would this help in this situation?
Yeah, if we look at performance, a data lake can give you better performance when you're talking about ETL. It can give you worse performance when we're talking about queries. So I probably should have separated that before. So because I can have folders in a data lake and I can fire up, as an example, a bunch of DataBricks clusters. I can fire up 100 clusters that are hugely huge, and I can clean that data very quickly. However, if I want to query that data, that's where we can have a slow experience. If I'm trying to query it from a Power BI or even within a Synapse Spark notebook or a SSMS, to query a file in a Delta Lake will be slower than querying it from a relational database, just because the engine behind it is, there's no things like statistics or query plans. Those kind of things are missing. So they could be a lot slower than a relational database.
Okay, but what kind of a transformation would happen? I mean, I'm really I cannot imagine. Yeah, so because if the data lake is supposed to have the raw data, so I can understand a few things like probably fixing default values or something like that. But what kind of a heavy transformation needs to occur in this particular layer?
If we think of the data lake, it's just a file sitting there. So that file has no indexes on it, no statistics on it. There's no query plan. There's no massively parallel processing technology behind it to make it go really millisecond response time fast. So if we copy that into a relational database that has those features, even indexing is just a major one. I can make that data go a lot, querying that data go a lot faster than if it's sitting in a file.
No, my question is, in the data lake, what kind of a transformation is needed to go from a raw to a, let's say from a bronze to a gold level of data? Because what I understand is, in the Synapse or in the data warehouse is the place where you're going to join different data and probably do transformation on that end. Yeah, if you consider join as one of your transformations, but on the data lake, other than probably handling null values or probably handling some default values, I really don't see what kind of a transformation should happen on a data lake to fix, to make the data more clean.
Yeah. If DataBricks calls it bronze, silver, gold, which is the same thing as raw, clean presentation. As I go from raw to cleaned, obviously I clean it. I may put it into a type of file structure like Parquet that's more conducive for queries to run faster on it. I may then take that clean data in Parquet format and I may aggregate it so it's quicker to run queries and put that in a presentation layer. I may join it a certain way. So that's where we get the presentation layer. It can be optimized for queries by doing things like aggregating the data. So that's the big difference between the three of them.
Okay.
Yeah, shoot me an email if you want a further clarification on that.
Yeah,
but
sure.
those different layers can have many different purposes, but the bottom line is to put it into a format that can make it quicker for queries to run.
Quicker for the queries to run so that the data can be moved to the data warehouse, right?
Correct. So it's quicker for queries if somebody with the skills can query off the data lake. Also quicker, to your point, to load it into a data warehouse, a relational database.
All right.
Yeah.
Okay. Yeah.
And then I see, how would you present the importance of a data warehouse to a non-technical individual in one phrase? Ooh, that's tough. What a challenge. The ability to collect and clean the data and put it in a central location to make it easier for business users to generate reports and get value out of the data. Ooh, hopefully that helps.
Yes,
All
I
right.
think it does.
So I know we're out of time.
Yeah, we are out of time. So I just want to thank you so much, James, for being here and everybody else. And I hope everyone has a great day.
Yep. Thanks, everyone.
All right, recording is going to stop. Bye-bye.
Thank you so much, Priscilla, for organizing this. This is definitely very, very helpful for